Good morning. Welcome back to the MCAT grind. Excuse the bad lighting, but I'm doing this at quite late. So we have Physics 6 about circuits. So let's speed run through circuits equations. We have what is called current, denoted by I and is measured in A. So 1 amp here, A-M-P-E-R-E. It's basically a measurement of current, and it is designated as coulomb per second. Think about how much charge is going through this point in the circuit per second. That is basically the traffic speed, the current. And it is charge over time. Simple. We have another property called EMF, or the voltage. So voltage is measured in joules per coulomb. So how much pressure is in each of the coulomb? How much charged is it? Like how strong is each of the charges? Okay, so how much energy it carries, how much luggage is in that car. Okay, now we also have Kirchhoff's rule saying that a current going into a junction must come out at the exact same amount. So a current coming out of this junction must equal to the two junctions coming in together. So how many cars going in must equals to how many cars going out. If 2 cars coming here, 3 cars coming here, 5 cars in total are coming out. We also have voltage source. So the source of the voltage, the battery, must equal the voltage dropped by whatever is used up in the circuit. So if we have a light bulb source here, and the voltage drop will then go ahead and use up all that voltage being used in the circuit. Okay, so we have a property called resistance. Resistance is how much back pressure. Sorry, let me change the lighting, actually. There you go. So how much is resisting that traffic? So think about the traffic stops and the flow is being reduced and the roads are getting tightened. Now, with a longer road, there's more traffic, right? There's so much congestion. But if the road is widened, then there's less traffic. Simple as is. So area, cross-sectional area of the circuit, if it's widened and thickened, more cars can pass through and more current and electrons. We have the basic equation of voltage equals current times the resistance. You can manipulate this however you want. Perhaps you want to find a current, you use voltage divided by resistance, or find the resistance by voltage divided by the current. Inside each battery, there's also internal resistance, the R internal. We also have internal current running through the battery, and the EMF subtracts the internal resistance, multiply the current, right? The voltage within it gives the actual voltage given out by the battery. Since the EMF within the battery, V, there's also an internal resistance running through the house. Imagine like at your garage, right? Your car needs to slowly back out of the driveway and before you can actually hit the road. So that's a little bit of a time you need to expend to get out of your driveway. Next, we have power. So how much power is generated. And you can think of this as current times voltage, which using this equation V equals IR, we get IR squared or V squared over R. Power is just how much is delivered in per unit time. And finally, we have our series connections, whether the resistors are connected in a row like this, boom, boom, and then you just add the resistance up, 2, 3, and that adds up to 5. But if they're connected in parallel, for example, 1 here and 1 here, then you need to do this formula. The 1 over the total equals the 1 over each individual one added together. So you need to add them all together and then do 1 over that. Okay. Next we have the capacitor series. Capacitors are little bridges. Think of them as drawaway bridges that shoots up like this to let the ships pass. They're like that and hold the cars there. So they hold the electrons there, hold the cars. So charges build up on one side, and once the drawbridge releases and let go, all that charge can pass through. So you have that potential build up. between the drawbridges. So letting the boat pass through the middle so the drawbridges come up. So you have that capacitor. Now, capacitor in series and parallel are opposite to resistors. Why? Because resistors are traffic lights, right? They're traffic lights, and if they're in series, oh, what a drag. You're congestion, and they add more traffic lights to this road. That's just so much time wasted. But if they open up new roads, more roads in parallel to each other, well, yeah, cars can be diverted into different roads. I don't mind the traffic light then, because you just have more different pathways to go into. That's why the more roads you add to the parallel circuit, the lower the resistance in total. Okay. Now, capacitors, however, if they're added in series, then it takes a lot longer for the charge to build up, right? Because if the first gate opens up, all the cars build up here, the drawbridges on the other side don't get any cars. And they slowly have to go through. But if they're in parallel, that means at the same time they fill up the cars together to build up the charges, right? Whereas if it's in series, then one is dependent on another. By adding more and more of them, you basically get less and less of the charges in total. Okay. Now, what we have here are measurement meters. We have the ammeter, which measures the current, I, and the voltage drop, the voltmeter, which measures like the point between here and here, how much voltage difference is there. The ohm meter measures the internal resistance at this point. It doesn't require a active circuit. So both the ammeter and the voltmeter requires a battery and the current to run through them. But the ohm meter can just function by itself, and you can later use the formula of V equals IR to find the resistance, current, and voltage, whichever one that you're missing. All right, so that's circuits. These are simple questions that you will definitely work well if you just do lots of practice on these types of adding up resistors, either using parallel or series, and capacitors as well. Very seldomly will you be tested on theoretical knowledge, but just plug and chug. Okay, take care.